Got it. All right, so we're still kind of taking a 10. Let me hit down there. I think he was here and might pop in and out. Oh, okay, got him. All right. I think that was the last one. Okay. So let me see. Let me check the poll really quickly. So there is a poll that I made available. It's available right now in Zoom. Similar thing, like what is it that everybody would like to do? Hopefully you guys can hear me okay. I'm assuming that it's working. I think I heard myself. Let me get back to sit in. Come on. Too, because I know if I don't save it, I'll lose my work. Then this one. Hope everyone had a good weekend. Let's see, edit. Okay, cool. It's ready to go. And the poll, let me look at it one more time. Okay, I think we're ready to rock and roll. So go through the homework. Okay, good. That's about where we should be. So this is the top of week 3, right? So this is one of those weeks that are a little bit intense as far as the course load. So because the intent is to make it through 4 sections this week, I did kind of dial back the amount of homework that I assigned for each section, right? So I think I essentially cut them in half since I'm doing double the work during this week. So this week, we like to go through sections 1.5 through 1.8. That's 1.5, 1.6, 1.7, 1.8. So today, we want to do our best to focus on 1.5 and 1.6. I think 1.6 is Leibniz notation and sum and difference rules. And then 1.6, I think, is the product and quotient rules, right? Okay, so I'm going to close this poll. Let's see. I am going to go ahead and start sharing my screen. Start that. And we're going to hop over to Pearson. And I think we got that ready to go. And I think my neighbor upstairs is starting up their job too, practicing the river dance. I don't know if you guys know what river dance is or not, but
yeah, that's hilarious.
But yeah, obviously when you start to string, you know, all these beings want to start making noise. So I think that they got, I swear, it's like a dog, a child, they're always bouncing the ball. I'm like, can you acknowledge that you're in the top floor apartment? People live under you. And then I swear, I think they'd be going through something because they be pacing like almost 24/7. It's like bad, but it's okay. It's just comes with living in an apartment. Okay, with people above and below you, because Lord knows I be torturing the people below me when I be gaming. I'm like, come on, you stupid.
He's in the back. He's in the back.
Right, exactly. I was like, come on, are you effing dude? Like, what are you doing? Like, come on, just get up. It's nothing to be. I'd be screaming my heart out. They'd be like, get mad. I'm like, my man. Okay, so with section 1.5, Leibniz notation and the power and some difference rules, right? So I'm just gonna kind of, what I'm gonna do, my intent is to just kind of start making my way through the homework and kind of dive into whatever concepts come out that I've already kind of gone through the lecture, but I just wanna try to get through as many of these as we can. We'll spend the first half of class on 1.5 and the second half on 1.6. So this first question, let's see, it's an augmented review, okay? So it says find any, actually, I'm gonna skip this one just because it's not really section 1.5. I'm gonna jump forward. A good amount of these are reviews. I kind of wanna get right into 1.5. If I need to go through any of these, let me know and I'll go back. Okay, let's back up. We got to 1.5. Okay, so I'm gonna start here with 1.5. Now, dy by dx, all right? So we have been going through, I know we've talked about the limit definition of the derivative, right? The derivative, what it is telling us the slope of the tangent line at a point, right? But generally speaking, to have the slope of a line, you need 2 points, right? So that's why we introduced this notion of derivative with this limit definition as a second point gets closer to a first, right? So then the actual derivative is like the limit as that h tends to 0, as that small change tends to 0, right? It's not, the main thing that you need to get out of derivative is that it's the slope of the tangent line at a point. That's essentially what it is, right? So when we're now here, so now what we're doing, we're just gonna kind of take into consideration that limit definition, and we're gonna start talking about shortcuts, right? So where we had this full page of going through the limit definition of the derivative, now we can just look at it and get the answer, right? So for instance, this one, we're asked to find dy by dx, find the derivative of y with respect to x. There is no x here, so this is a derivative of a constant. The derivative of a constant is, can anybody tell me that one? What's that result? What's the derivative of a constant? So if you think about this graph, it's just a flat horizontal line, right? If you pick any point on that graph and you draw a tangent line, it's basically going to be a flat horizontal line as well. I don't even know if you can call it a tangent line, but that slope is still going to be 0, right? So the derivative of a constant is 0. That's just one of our properties. You can verify that with the limit definition, but for right now, that's one of the shortcuts. Now let's do this one. Let me write this one out. It doesn't, you don't really need to write it out. I'm just gonna kind of talk my way through it. If you need me to write it out, just let me know and I will. So here, we wanna differentiate, right? So one of the shortcuts was that a constant times your function, the derivative of a constant times your function is the constant times the derivative, right? So essentially what that means is that that 4 can actually just go in front. You can almost just move that 4 in front and it'll work. So then when we go to take the derivative of the square root of x, we use the power rule, right? The power rule says that when you take the derivative, basically the exponent or that power comes down in front, becomes a multiple, and then you subtract 1 from the exponent. So square root of x is the same as x to the power of 1/2, right? So then if we bring that half down, so first I'm gonna just kind of type some stuff out. We have 4, that 4 is just persisting, right? We're gonna say times. Now if we bring that 1/2 down, I'm gonna go ahead and show the 1/2. So that 1/2 came from the exponent from basically square root of x. I brought that 1/2 down. Now we're gonna have x to the power of, now 1/2 minus 1 is a negative 1/2, right? So now we need to just go back and like simplify. So for instance, like half of 4, we can just that becomes 2, right? So we can just go ahead and make that 2. A negative exponent moves it to the denominator. And then, so you're gonna have 2 over x to the 1/2, but then x to the 1/2 is square root of x. So then ultimately this becomes 2 over square root of x, all right? Now, if I need to write that out, I kind of talked my way through it. If I need to write it out, let me know. Let's just try another one really quickly. Let's try another one, okay? So find a derivative. Do I need to write this one out? Yeah, I'm gonna go ahead and write this one out because I feel like it'd be easier to explain. And again, my upstairs neighbor is doing her job. I don't know, I get it, like, because I think it's like a female and like they like to work out in their units because of like privacy and stuff. You know, like if you're a female, and so it's just like, because we have like this nice gym, I'm like, this is nice gym downstairs, but I get female, I'm not really wanting to work out in the gym. I get it, but it doesn't make it any less like frustrating. But it's okay. All right, let me get a copy of this guy. It says find the derivative. And come on.
Yeah, for sure. Because I know last semester I did this. I like had like 2 study sessions. I like got it, but we like already moved on to something else. So I know it's like super fast paced.
Go ahead. Is somebody in the waiting room? You guys okay? Okay, I'm gonna keep going. Let me check the waiting room real quick because I'm sure some people have come in. I have not. I think we're okay. I'm gonna keep moving. Oh no, there are people in the waiting room. Let me get them. All right. So I turned off my notification when people come and go because it was totally distracting me. So that's why I didn't know they were there. Let's see. That might be better. The rhythmic thumping. It's soft. Like it's noticeable that they've at least adjusted, but it feels like that William Tell beating heart thing. It's like this constant do 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 do, and like when you don't want to hear that, it's like you can feel it more than you can hear it, and so that's the part that's like maddening because you can feel it. Okay, we're working here. I think I got those. Let me go ahead and hit save over here so I don't lose my work. Okay, so find the derivative, right? So find the derivative. So let me start by rewriting some of these expressions. So we want to find d by dx, or the derivative with respect to x. Now this eighth root of x, I'm going to rewrite that as a power function. So the eighth root of x is the same as x to the power of 1 over 8. Okay, and then this 4 over x, I'm going to rewrite that as 4x to the minus 1, right? So this is what we're actually taking the derivative of. Now we can kind of use the power rule. So what the power rule says is when you have the derivative of a power, that power you can basically bring it down in front and subtract 1 from the exponent, right? So then this is going to give us 1/8 times x, and then 1/8 minus 1 is going to be what? -7 over 8, -7/8. Now, if that -1 comes down, double negative becomes positive, so that's going to become positive 4x to the minus 2. Okay. So let me see. What I would do here, on bottom, we're going to have 8 times the 8th root of x to the power of 7, or 1, and then on the second part is going to be 4 over x squared. Okay. Let me submit this result and see if it works. Hopefully we don't have, if we have to make adjustments, we will. Like, because at this point, it's just like, okay, what form do they want the result in? So maybe I should do a split screen. Let's see a little bit better. That's fine. Kind of a lot to type. I'm going to do 1 over 2 in roots. Power of 7 is the first expression. I think this is okay. We're going to go with it. Come on. Plus 4 divided by x squared. Okay. Cross our fingers. All right. Stop me if anything isn't clear. We can talk about it. Let's keep moving.
Hey, Professor, is this the homework that we did already?
No, this is section 1.5, right? So
this is the next the lecture.
Yeah, this is for this week.
Okay.
This week is 4 sections this week, 1.5 through 1.8. And so yeah, I try to keep recordings of all of our interactions. The lectures are recorded through this week. The homeworks are assigned. We can anticipate exam 1 during week 6 over chapters 1 and 2, right?
Okay.
Okay. Let me get a copy of this question. Work through this one. So I think the Leibniz notation is the dy by dx thing that you're. That's Leibniz notation. That's all. And again, I do go through more details in my recordings. The lectures. Let me make questions as well. So it would be a good idea. let's see. This is question number 8, or this is question number 8. This comes from section 1541. I went on the question ID available so that you know where in the text these questions are coming from. These are basically the exact same questions that's in the back of each section, just different numbers, right? So we're asked to find the derivative of this guy. Okay. So one thing I want you to see is that we're dividing by 2, right? That's the same as 1/2 times this guy. So I feel like our exponent is already in a form that we can use, right? So now when we're going to take the derivative, so when we go to find f prime of x, the 1/2 essentially just stays, right? And the derivative of this power function, again, the exponent just comes down in front, and then you subtract 1 from the exponent. So the 1/2 stays, the 6/5 comes down. We're going to have x. Now 6/5 minus 1 is going to be the same as 6/5 minus 5/5, leaves us with 1/5. Right? So just adding and subtracting fractions. Okay, so then we can simplify this. This 2 turns this 6 into a 3. Okay. So then, and we can just match what the formula left it in. Since they started with a rational exponent, we can leave our result with a rational exponent. So then ultimately we can stop at 3/5 x to the power of 1/5. All right, we should be able to stop there. So like down, oftentimes you can just match how you started. Okay. Let's do the split screen.
Hey, Professor, I got a quick question. So my question is for the quizzes. I remember you saying something about like there being a hard deadline and then the soft deadline for the assignment.
My answer.
Huh?
Oh man. 3/5 x to the power of 1/2. So then 3.
Hey, Professor.
Your mic is like kind of going in and out. Can you hear me?
Yeah, I can hear you. Can you hear me?
Yeah.
All right. So my question was it was a quick question about I remember during the syllabus day where you was telling us about the syllabus and your rules and stuff about the homework, quizzes, exams, and whatnot. For the quizzes, I know you said there was a hard deadline, or for one of them, I know there was a hard deadline and a soft deadline. Hard deadline was at the end of the semester. Soft deadline was the deadline that was set already on the assignment. And you said you take off, I think it says 10% for
That's correct.
It being late. Correct?
Yeah, it's only a 10% penalty. So like if you can work on any assignment past the deadline and you can still earn up to 90%.
Okay, so the quiz is included in that as well?
Yeah, all the times. Homework, quizzes, and exams.
All right, thank you.
It's essentially the same format for all assignments. Only thing that's a little different is when you're going to see the exams when they come out. They basically the questions are going to change each time you take the exam. It'll be the same content, but just different questions. So you get unlimited attempts, but those rules apply. Unlimited attempts, only a 10% late penalty, and a hard deadline of like May 1st. Yep, these are good questions. Okay, let's go on to the next one. If f of x is this, find f prime of 14. Okay, I think I'm actually just going to work here instead of writing this one out. I probably should write it up, but I'm not going to right now. I'm going to try to get to this without. So now, if we have f of x equals square root of x, when we go to take the derivative, the 1/2 comes down. We're going to have x to the power of a negative 1/2, right? So now that's the derivative, not simplified. And then they're asking us to basically, when x is 14, we plug in x equals 14. 14 is what, 7 times 2? So I'm going to rewrite this and put it in radical form. A negative exponent moves it to the denominator. So we're going to have 1/2 times the square root of 14. All right, hopefully that's okay. 1/2 times the square root of 14. I think that's it. Because again, the negative exponent moved it to the denominator. X to the power of a half is the square root of x. And then just basically evaluate when x is 14. 14 is not a perfect square. 14 is what, 7 times 2? So there are no perfect squares. So that's as exact as we can get it. We have this y. So again, dy by dx is Leibniz notation. It just means the derivative of y with respect to x. It just means you just take the derivative like we've been doing. It's just another way of saying the same thing. So it says if y is this, find the derivative, find dy by dx when x is 2, right? Okay. So now we have this 1 over x to the power of 6. We can rewrite that as x to the power of negative 6, right? So then when we go to take the derivative, the negative 6 comes down. We're going to say times. It's basically going to be what, x to the power of negative 7? Because we had a negative 6 there. But then now it's saying let x be 2. So if that's x to the negative 7, let me go ahead and put that in fraction. So that's x to the power of 7. But now we're going to let x be 2. So then 2 to the power of 7. I know 2 to the 5 is 32. And then 64, I think it's 128. So then we'll have 6 over 128. But then we need to reduce both of those. We can at least divide them both by 2. That'll turn this into what? 64. 64. And that'll turn this to a 3. That might be it. 64 is not divisible by 3. Simplify your answer. I'm going to go with this. So what this is telling us, so for this function, 1 over x to the power of 6, if we were to look at that graph, and we go to when x is 2, if we drew the slope of the tangent line when x is 2 of this graph, it's going to have a slope of a negative 3 over 64, right? The derivative is telling us the slope of the tangent line at any given point on the function, right? So find the equation of the tangent. Now we're asked to find the equation of the tangent, right? So again, the derivative tells us the slope. Then once we have the slope at a point, now we're back to college algebra where we can find the equation of a line. I feel like I should write this one out. This one has like several parts, okay? Find the equation of the tangent line to this graph. So copy the original question to work with. And we're going to work here. I can't help but to say the following, and let me not say because it's going to spoil it, but I did complete the latest season of Ozark. It was good. I'm going to leave it at that. I didn't even want to say that if you want to watch it. I want to talk about it because I don't want to ruin it. I'll give you 2 weeks if you intend to watch it. After 2 weeks, if you haven't watched it by then, you know, the spoiler alert is on you. I'll give you 2 weeks. So I try to give people some time and I'll give them a warning, you know, so I don't spoil things. But it was good. I enjoyed it. They had that classic Ozark. Okay. Finally, quit shameless, like, man, I'm doing marketing for these people. I need to get my own product out there. I'd be marketing for other people's stuff so much. It'd be so bad. Anyway, let's keep it moving. Okay. I only want to stay in the section for no more than about 10 more minutes, right? I want to move on to section 1.6. Let's see. So find the equation of the tangent line, right? So now we're starting with, and I think we can suppress this for now. We're starting with f of x equal to 1 over x squared, right? Now, if I want to take the derivative, I like to work with something like this. I like to rewrite it in this form as a negative power, right? So then when I go to do f prime of x, when I go to take the derivative, the negative 2 comes down, and I subtract 1 from the exponent, that's going to become negative 3, right? Find the equation of the tangent line of the graph of this with value of x. So this will give us a slope for any value of x. We need to see what value of x are referring to. Oh, we got several parts. Okay, I missed that. Multiple choice. That's one from this section. We have our derivative. So then we have a part A, B, and C where we want to find the equation of the tangent line at these different values of x, right? Okay. Let me check this one really quickly. Something check and make sure. Do this really quickly. Yeah, I still rather leave that notification off because it's totally distracting as people come and go. Get some attendance. Like I found some more people in the waiting room. Let's see. Here. This one. There's another one. That I don't know. It's just interesting. Like they do a good job of capturing like the essence of like the martial arts energy, in the sense of just it's so nuanced. It's not even funny because like if you're a trainer, you know you don't want to give people a false sense of security because that thing is real. And then it's like if you have a school, you actually do have people coming around challenge you. If people get hurt, it'd be nonsense stuff too. Like I felt like Cobra Kai, and the funny thing is, I actually like so I do like Uber. Sometimes I do Uber Eats just for the sake of doing it. And one time I delivered Uber Eats to like one of the stars on there. I was like, "You look familiar. Are you one of the stars on the thing?" She was like, "Yeah." I was like, I was totally like geeking out a little bit, just a little bit. So it was just fun. I got to meet him, you know, gave her the food and kept it moving. Okay, let me see the time. Yeah, let me try to wrap this one up so we can get to the next section. So we have our derivative. So then let's talk about part A, all right? So this is saying at the point 1, 1. So when x is 1, the corresponding y is 1. So then we need to find, so first let's find the slope. So then f prime of 1, man, I don't know why I keep doing that. F prime of 1 is going to be -2 times 1, which is -2, right? So that's the slope. We have a slope and a point, so I'm going to use, I just like to do y equals mx plus b. I think the book does the point slope formula, y minus y1 equals m times x minus x1. That's fine and it works. I just prefer this technique. So the -2 is our slope, right? So we have our slope. When x is 1, the corresponding y is 1. Only thing we don't know is our b and the y-intercept, right? So if we add 2 on both sides, the y-intercept is 3. So then the equation of the tangent line is going to be y equals -2x plus 3. I mean, they have not stopped. Okay, so this is it said find the equation of the tangent line. So that should be the equation of the tangent line. Now we could graph this line, and it should create a tangent line, but I'm just gonna kind of put it in the Pearson line. I'm gonna paste. Oh, where's my work? Cool. Okay, cool. All right, so part B. Okay. So B, B says at -3, 1 by 9, right? So we have f prime. So then basically we need to find f prime when x is -3, right? So there's going to be -2 times -3, which is 6. So we have our slope. Again, every time we use a formula, write it down. That helps you to remember it. Okay. So then the y is 1 by 9. All right. The slope is 6. The x value is -3. Only thing we don't know is b. Right. 6 times 3 is -18. So we add 18 on both sides. I don't know. 90 plus 72 is 162. So then 163. This is 163 over 9. Basically, I did 18 plus 1 over 9. I'm going to go with that. So then my equation, my y equals my slope 6 plus 163 over 9. It is, so let's just go with it. Again, we could graph it and check before we submit it. I'm just trying to move on to the part. And then for part C, we have 2, 1 by 4. So then f prime when x is 2, we said it was -2x. Erased. Yeah, we got to go back. All of this is wrong. Somehow, when I moved it, I lost some of my work right here. I felt like something was off. Right here, it was -2, right? And I think we had -3, and it got erased right there. So we got to go back. -2, right? It's supposed to be x to the -3, so we have to fix all of these. So I'll do those in red right here. This one's supposed to be -3 here. So I think that one stays the same. So we can leave part A. But then it looks like this one there. So we got to fix that one. So let me get rid of that stuff. And I'll just put the result in red. So delete. I'm going to move this down. Yeah, I think because I noticed that something was missing. I thought I got everything, but it just dawned on me that I was missing my -3 when I kind of readjusted things. Some stuff got erased. I don't know how, but that's technology. Okay. So let's keep going here. Actually, we said we're going to do it in red. So this is going to be equal to what? -2 over 27? No, positive. Because this is basically -2 over -3 cubed. The cube of a negative is still negative, so then that becomes double negative, it's positive. I know that's kind of a lot. If you think about it, you see it. 3 cubed, 3 times 3 is 9 times 3. So that's going to be 22 over 27, right? That's what that one simplifies down to. So that's the slope. So then 1 by 9, the slope we got was 2 by 27. Our x was -3. The only thing we don't know is b. Okay. This 3 turns this 27 into what, 9? So we have a -2 by 9. So if we add 2 by 9, we get 3 by 9, which comes down to 1 by 3. I just basically just simplified it, right? So then here we get y equals 2 by 27 x plus 1 by 3. Okay. Now I feel like we should probably check it, but again, I'm not going to because we have Pearson and I'm really trying to move on. Okay, let's go with that. I feel better about that. And then we need to catch it here. So I think we had negative, now this is a big last part in red, -2x to the -3. But again, we said the x in this case is 2. Did we do x equals 2 already? What did we just do? That's what, 2/8? That's a negative 2/8, which reduces down to a negative 1/4. And like, this is why I wrote this out, and I'm still not writing it all the way out, but when you don't write it out, you're more likely to make a mistake and miss something, right? You have to kind of write it all the way out, take your time, so you reduce your chance of missing something. Okay, but I'm gonna go with this. So then we're gonna use y equals mx plus b, okay? So the y we got was 1/4. The slope we got was a negative 1/4. The x was 2. Only thing we don't know is b. So then ultimately b is going to be, so 1/4 of 2, 2/4 becomes what, a half? So we add a half to both sides, which is the same as 2/4. So that becomes 3/4. So then the equation of the tangent line should be y equals, we got a negative 1/4 x plus 3/4, okay? All right, hopefully we were able to catch our mistakes. Again, we could check it. If you really wanted to check it, graph the original, and then you would graph these lines on the same graph, and they should create tangent lines at those x values, right, at those points. But what I'm going to do, in the interest of time, I'm just going to submit them in Pearson. Gotta catch them all. Okay. I don't know anything about Pokemon other than gotta catch them all. The movie was actually kind of fun. The live action. Okay. The equation of the tangent line, right? For part A, we got this. So let's submit this and see how do we do it. Type an equation using x and y as a variable. So we got y equals negative 2x plus 3. Cross our fingers. Look at that. Okay. Part B, we got this. After catching a mistake, we got y equals, man, I had to go into like a Zen state to ignore them. I think I gotta close this out and click here to get this to work properly. Okay. We got 2/27 x plus 1/3. Okay. Cross our fingers. That is good. All right. And then, and all the time, and then the last one, I told you they're making me look, and it's not really them. I'm just using them as an excuse. Come on, let's try this again. All right. Negative 1/4 x plus 3/4. All right. All right, that was an adventure. Okay, so I want to kind of go ahead and move on. That was section 1.5. We got through a few questions there. I want to move on to section 1.6. So I'm going to close this out. It's somewhere here. Green flags are prereqs. This is what the top of week 3. Okay, so you see the due dates on the far left. Even though those say past due, you should be able to work on all of those assignments. The current assignments are these. All right, let's go to week 1.6, the product and quotient rules. All right, so we're going to start here. Is that 1 point? That's still 1.5. Let me try to get to a question from 1.6. Okay. So the product and quotient rule, right? So in the last one, I think we went through the sum and difference rule. The derivative of a sum is the sum of the derivatives. The derivative of a difference is the difference of the derivatives. It's very natural, like the way when you start working them. Hopefully you were able to see them in action and catch them. We also saw the power rule where the derivative of a power is the power times the derivative. Then you got to subtract 1 from the exponent. There's a little bit more to it. But. So now the product rule, so for instance, with this one, we want to use the product rule to take the derivative. So the product rule, there's a little thing. It's basically the first times the derivative of the second plus the second times the derivative of the first. That's the product rule, right? So again, product rule is the first times the derivative of the second plus the second times the derivative of the first. So you see, it should be, it looks like it's part A, right? So the first, which is x to the power of 7, times the derivative of the second. So that's going to be times 5x to the power of 4. Where'd it go? Okay. So that's the first times the derivative of the second plus the second times the derivative of the first. So x to the 7, that derivative is going to be 7x to the power of 6, right? Okay. I'm just going to hit check my answer. On to the next. Apply. Okay. So, okay, that's interesting. So then if we say x to the 7 times x to the 5th, we add the exponent, so that's going to become x to the power of 12. So I guess they're finding the derivative two different ways and comparing the results. So let's come on. Or are you going to let me click in? No? Okay, let's go like this. Oh, okay. Let me enter to the next one. The derivative of x to the 12, that's going to become 12x to the power of 11. 12x to the power of 11. Right? The power comes down, you subtract 1, you get this. That's the power rule. That's it. So do they work out? If we multiply, yeah. 7 plus 4 is 11. That's going to be 5x to the 11 plus 7x to the 11 is 12x to the 11. That's interesting. Next one. The product rule to find a derivative. Okay. So if we said the first times the derivative of the second, so it should be C. Go ahead and take the derivative of the second. We got z cubed. That's going to be 3z squared. 3z squared. If negative z is -1. And then the derivative of a constant is 0. So that plus 4, that derivative is 0. So the first times the derivative of the second plus the second times the derivative of the first. So for that first part, derivative of a constant is 0. For the negative z squared, the 2 comes down, we're going to get -2z. I'm going to hit enter. Expand the product. So they basically want us to multiply and simplify. I'm just going to attempt to do it all here. I probably should write it all out, but like this. Who is this? Okay. So if I say 6, so I'm basically foiling 6 times every term in the trinomial plus the negative z squared times every term in the binomial, every term in the trinomial. 6 times z is going to be 6z to the power of 3. And go ahead and do that minus z. Now, if I say z squared times z cubed, that's going to be what? Z to the power of 5. You add the exponents. Z to the power of 5, right? So that's that. Then we're going to say minus 6z. Okay. Positive, so we're going to say plus z cubed. Okay. 4 plus 24 minus 4z squared. 4z. I was kind of hoping that some of this stuff would match up, but I guess this is easier. We don't have to combine the like terms. So go with it. Oh, there are some like terms. There's one. So that becomes 6z cubed plus 1 is 7. So we should have a 7z cubed. And we have used this guy here. Writing this out, I'm just not doing that. Let me see. Power 5. I don't think there are any other like terms. Okay. approach. Oh, okay. So now they want us to basically take the derivative of the product. We could use the product rule where we go first times the derivative of the second plus the second times the derivative of the first, or we can just use this take the derivative of the expanded product. For me, looking at this, I feel like the expanded product would be much easier to take the derivative of in this case. Okay. So if we do, I'm going to use the expanded one. 7z cubed is going to turn into 21z squared. Okay. Minus 5z to the power of 4. Minus 6. So that's gone. Then minus 8z. Okay. I just use the expanded one. Oof. Like that's why it's like torture, because it's like incessant. Ooh, okay, let's see. We could use the product rule, or we could expand it. First times the derivative of the second. Yeah, I'm gonna expand it. I feel like that'll be a little bit easier. So let me get a copy of this. I want to give out here. Oh my god. Ooh. Got me nuts. Into this unit, I was like, yo, give me something on the top floor. We don't have anything available for a few months on the top floor. And it was nice because like these are brand new units, so it's like, you know, I didn't want to pass on them because nobody else lived in here, so there shouldn't be like any bugs or anything like that. It's nothing. It's clear. It's just me. It's my energy. So I like it, you know. Anyway, it is what it is. I already knew that was part of the territory. Just suck it up and keep moving. Okay, so we could do the product rule here, but I felt like that's just going to be way too much. So I did like their technique of expanding it first. So I'm just going to expand this one. All right, I feel like that for something like this, that's just better. We don't always have that as an option, but when we do, just decide which one you want to do. So if I were to expand this, so let me see. So we x, no. So 35x cubed okay, we can do that. So that's going to be plus 5x. If I do outer, x squared times the square root of x. I'm going to rewrite it. It's basically going to be 2 plus a half. So x to the power of 5. 2 plus 1 half. 2 plus 1 is 4. 5 halves, right? I keep, for some reason, I kept wanting to do 5 fourths, and I was like, that's not right. First outer inner. So 7 times 4 is 28x. And last is going to be 4. I'm going to put it as x to the 1 half, right? So then we're going to do g prime. Now, if anything is not clear, just stop me and we can like go back. So now when I go to take the derivative, 3 times 35 is what? 90 plus 15 is 105. X squared. 5 halves times 5 is 25 over 2. 2 over 2, you get 3 over 2. 28 is 2x to the minus 1 half. So since we started with radicals, we should probably finish with radicals. So then g prime of x We still got the 105x squared. That's going to be the square root of x cubed. So you can say 25 over 2 square root of x cubed plus 28. And then that's going to be 2 plus 2 over the square root of x. Okay. This is what we got. Man, I feel like I need to. It's like I can feel it in my chest. It's never be that. All right. Let me see. We are here. How much? Like that. This one looks a little bit less. Okay. We got square root of x cubed. Okay, we got that one. Plus 28 plus 2, that's not a 2 over the square root of x. Okay. All right, moment of truth. Oh, let me think about it. Okay, let's check our numbers. 105x squared, 25 over 2 times squared 28, 2, okay. Let's see. So let's back over here. Let me see. Now we expanded. 5 times 7 was 35 x cubed. I feel good with that one. Outer 5 x squared. So now 1/2 plus 2, 4, 5 over 2, right? I'm gonna go with that first. Outer, inner, 28x, and last is 4 times the square root of x. Okay, I feel good with that first line. So then we're going to take the derivative. 3 times 30 is 90 plus 15 is 105. I feel good with that. That becomes x squared. 5/2 times 5 is 25 over 2. Oh, yeah, no, we got that. Cube 3 over 2, right? That feels good. 28. 1/2 of 4 is 2 to the negative 1/2. The other thing I could think to do, and it just might be the form that might be what is causing the trouble. Like, I feel like the answer is not wrong. I feel like it, because sometimes it's just the form. So what we're going to do here, instead of expanding it, we're just going to go ahead and actually do the product rule, right? Let's just do the product rule. So let me start by getting a copy of the original. I told you, like when you need them to be quiet, then they all want to start singing. And like they've been quiet all day. Like my dog has been asleep, my neighbor has not been working out. But the minute I need them to be quiet now, I don't know why this isn't working. Let's see. Let me try to go like this. Let's see if we get out. I don't want to keep you longer than no more than about 10 more minutes. Let's see. So we got 5x squared plus 4. So now if we apply the product rule directly, okay? So the product rule goes the first times the derivative of the second plus the second times the derivative of the first, right? I'm just going to do that. G prime of x. So the first, I'm just going to rewrite it times the derivative of the second. So the derivative of 7x is just 7 The derivative of square root of x is 1/2 x to the negative 1/2, right? That's the first times derivative of the second. Now I'm going to say plus, I just run out of space and just drop it down to the next one. We did the first times derivative of the second plus the second first. So 5x squared is going to become 10x, and then that's it. Right? I'm just going to shrink this down to get this on one line. Hopefully we can make it. Where my AirPod is. Okay. Okay. So we got this. Let me see. Are there any common factors here? No. This one. And I feel like if we were to expand it, we would get the same thing as above. But I think they just really wanted a different form. Again, I haven't really confirmed that the first one was correct. I still think it is correct. I would just need to expand this out and then simplify it down to see if we get the same thing. But instead, what I'm going to do is, again, I'm just submitting it on Pearson just to try to get to at least one more question. This result. Now, what we could do, let me go to they don't have view on example. Okay, I was going to click on view on example, but it looks like there isn't that option for this one. So we're just going to submit what we got. Okay. Well, we got the first part, we got what? Squared plus 4x, 5x squared plus 4, right? Next part, we got 7 plus, now I got a 1/2. If you got an x to the power of negative 1/2, so that's in the denominator. This is square root. The square root of x, okay? Plus root x. So we got 7x plus the square of x. And then this is it. If this ain't it, then I don't know about this. 10x. Okay. Got it. Good. All right. So now again, we can still confirm. Like, I feel like the first thing that we submitted was not incorrect. It was just not necessarily in the form that they wanted. If I were to expand this out and simplify, I can show that they're the same, right? And you can get credit for something like that. But you saw what we did. The first time we expanded it, and then we took the derivative. But then when that didn't work, we were like, okay, let's go back. And we just applied the product rule directly. If you're on an exam and you did that first technique and you think it's right, and you want to credit forward, what I would need you to do is apply the product rule direct. Like, you would have to write it up. Apply the product rule directly, where you do first times do the second one, that whole thing, and then you get your answer, and then box the correct answer. And then if you expand it and connect it to your original answer, I can give you credit. Like, just don't make me have to go into that work. If you do it, I'll go through it and you send it to me. Say, hey, I got this answer. This is one of those questions you were talking about. I can look at it and then just don't give me a whole bunch of extra work. If you do the work for me and I'll look it over. Like, I can go back and give you credit for questions retroactive if you wanted to go that route. If you need to. Anyway, let's do another one. I want to keep you past 710. Okay, so now this one, Quotient Rule. Oh, there goes my headphone. Darn. Let me put my other one in. Okay, give me a second, guys. And see, like, can hear me. You know, with the technology, I mean, they do have like where I do have the adapter. I think it's still get back up to speed. Okay. So hopefully it looked like it's connected again. Hopefully you guys can hear me. Like I'm working on an iPad and like, you know, they do have the adapters where you can have a direct line into the device for your headphones and things, but you know, it's designed to be with the AirPod. And so, you know, usually a wire connection is always better than a wireless, but you know, it is what it is. Okay. So this will probably be the last one. We're asked to differentiate. This will be an example of us using a quotient rule, right? We could get this to a common denominator and condense it into one thing. I'm just trying to think what would be better. Let me, yeah, let's do that. So let me do this. I want a copy of this. All right. So here, and I'm including the question ID so we can at least see where these questions are coming from. Okay. Come on. This. Good. All right. Let's give this one a go. Okay. So I could apply. We're going to work our way through the quotient rule momentarily. I'm tempted to apply the quotient rule just on that first term by itself, but I think what I'd rather do is just go ahead and get this into one fraction. So I'm going to combine these using like algebra into one fraction or one rational expression, and then take the derivative of that. So the common denominator here is 9x plus 8. So what we need to do is multiply the second term by 1 in the form of 9x plus 8 over 9x plus 8, right? So then when we do this, on top, we're going to have 8x minus 3. If we distribute the x cubed, we're going to have plus 9x to the 4 plus 8x cubed, right? That's all on top. There are no like terms to combine and simplify. And then now the denominator is, that's going to be a lot. 9x plus 8, right? That's the denominator. Okay, let me think. All right, so now the way that the quotient rule goes, the quotient rule is the bottom times the derivative of the top plus minus the top times the derivative of the bottom. Another way you can remember that, over the bottom square. Another way you can remember it is like low D high minus low D high minus high D low over low low, right? So low D high, so the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom square. Low D high minus high D low over low low. Another way, let's write it here, right here. Low D high. Here. So in quotient rule, low D high minus high D low over the bottom square or low low. Right. So when we go to find G prime here, so the bottom is 9x plus 8. Bottom times the derivative of the top. Again, unfortunately, we don't have any, we can't get that down further. So, and I'm going to put it in descending power order. So I'm going to start with that power 4 first. 9 times 4, that's going to be a 36. And that's going to become x to the power of 3. And then 8 times 3 is what, 24? X squared. And then plus 8, and the derivative of a constant is 0. So that's the bottom times the derivative of the top minus the top. I'm running out of space, I'm gonna go over here. 8x minus 3 plus 9x to the 4 plus 8x cubed. Top times the derivative of the bottom is just 9. Okay. And then we would say all over the 9x plus 8 squared, right? Let me shrink this down and see if we can simplify this down any. Okay. And then that's supposed to be squared. Okay. So again, we said the bottom times the derivative of the top. Here, let me expand it back first. So we said the bottom, you see it here, times the derivative of the top, you see it here, minus the top times the derivative of the bottom over the bottom squared. Okay, low D high minus high D low over low, okay? Let me see if I can get, now I mean, we can obviously expand that. I don't know if they want us to expand that or not. We can expand this out, combine like terms and simplify down. We might need to do that. I don't see any common factors or things that we can factor out. So again, we could expand combine like terms. Maybe we should. That's a lot. Let me try to submit this. Let me see if this works. If this doesn't work, then I'll try expanding. If expanding it doesn't work, then I'm gonna let that one go. Okay. All right. Let's see if it looks. Sometimes these are just like kind of weird like that. Okay, let's start by shrinking this down. Okay, I think that helps. Okay. Top, the first part that we got was 9 that times. We got 36x squared, 24x squared, 24x squared, plus 8. Thank you. Stop. I am wrapping up. We're going to say minus. Now, the next part that we got 8x minus 3 plus 9x to the 4, 9x to the power of 4, 8x cubed, so plus 8x cubed. And then the next part we got was a 9. I'm just going to leave that like that. And then the bottom, come on. We got was 9x plus 8 quantity squared. 9x plus 8 squared. Okay, let's cross our fingers. Yeah, that's what I did. Okay, let me see. Use the quotient rule. Blah blah blah. Blah blah blah. Blah blah blah. Blah blah. Oh, yeah, we did that. I mean, let me check. Let me check it one more time. Bottom times. Oh my goodness! Stop. Bottom times the derivative of the top minus the top times the derivative of the bottom squared. Another thing we could do is just apply the quotient rule. Like, don't get one denominator. Let me try that before. I'm going to save what I had before. I'm going to try not getting one denominator first, and then see if it gets us something better. I got a couple of things I can try because we can still simplify that result that we got. We can like expand those out, combine like terms, and boil it down. We could do that. I'm trying to think if that would be the better move. Let me try the low D high without getting it to one denominator. Let me try that first. Okay, so if I were to, let me start with the original. And I see the time I'm trying to get you guys out of here. G of x, we got 8x minus 3, 9x plus 8, x cubed, right? So now, if we just apply the quotient rule from here, instead of combining this into 1, so then G prime the bottom, which is this 9x plus 8, low, d high, so the derivative of the top is just going to be an 8. The bottom times the derivative of the top minus the top times the derivative of the bottom is just 9 over the bottom squared. Okay, this doesn't look a lot better. And then the derivative of x cubed is going to be 3x squared. And I think we can honestly leave it like that. Let's try submitting this and see if this works. Are there anything like terms that we can factor out? Okay, let's try this and see what happens. I'm going to try this. Okay, because a lot of times with these, you should keep it as simple as possible. And sometimes I do have a tendency to overcomplicate. Okay, I'm going to scrap this. And I don't think what we did was what I think it is. That's usually what it is. 9x plus, we could distribute that 8. Oh, I guess we could simplify that down. Yeah. Let's simplify that numerator. Because those are simple to simplify. Simple to simplify, boy. I see the time trying to get you out of here. So let's go a little bit further, right? Here. If we distribute the 8, 9 times 8 is what? 72x plus 64 minus 72. That's not a 72. Minus 72x plus 9 times 3 is 27. Okay. And then everything else stays as is. 9x plus 8 squared plus 3x squared. Now look, it looks like this cancels this, right? That's 80 plus 11 is 91. So then we get this on bottom. 80 plus 11 is 91. We get this on top. Now we could combine this into one fraction, but I'm going to go with this one. Hopefully this gets us there. All right. This is going to be all because I'm going to get you guys out of here. I don't want to kind of make this one anymore. Okay, let's try this. Are you doing that thing again? So we got 91 over x plus 8 quantity squared, 3x squared. Okay, let's go with that. Oh, boy, that was an adventure in the nick of time. That's how these things go, though. So what we got the first time, part of me feels like if we expand it out and simplify it down, we'll eventually get here. But you saw how we adjusted, right? The first thing we tried combining it into one fraction and it just made it worse, right? So when that happens, just put a pin in it and try something else. So then we went back to the original, and I'm kind of like back over here on the right. We went in here, I guess we can get rid of this stuff. We went back to the original, which you see here at the top of the screen. And then we took that derivative. We took the derivative of this guy, right? And then you see it here. And we almost submitted this. Then it dawned on me, I was like, wait a minute, we can simplify that down further, the numerator, right? So then when you expand it, we got this. We had some nice cancellations going on. We just got lucky. Combined like terms, we got this. And we just left this over to the side. And then we were, that's what they wanted, right? Okay, so that is exactly time. I tried to get you out of here a little bit earlier. On that note, we're gonna end the session here. If there aren't any questions, we're gonna end the session here. From one beautiful mind to another. Enjoy the rest of your day. Take care, guys. Peace. You guys have any other questions before I end the thing? Going once, going twice. Forever hold your peas and rice. Okay, guys. From one beautiful mind to another, enjoy the rest of your day. Take care. Peace. Go ahead. Yeah, take care. Any other questions before I go? Going once, going twice? Okay. Let me check the chat real quick. Is this person still here? There was a question in 1.5, number 13 and 10. They're still here?